Good day. Today we will be going over probability. Okay, so what is probability? Probability is the likelihood of a specific event occurring. So it is a chance that something can occur. So if we have a coin, like we have right here, then our probability of landing a heads or tail is 1 out of 2 because we have two choices. So this is one choice. This is another choice. So we have a 1 out of 2 chance of landing a head and a 1 out of 2 chance of landing a tails. Now if we go down to the 6-sided die, we have 6 possible outcomes. We can get either a 1, a 2, a 3, 4, a 5, or a 6. Now, because we have six total possible outcomes, that means the chance of landing any one singular outcome is 1 out of 6. So pretty simple so far. Where it gets a little bit confusing is understanding how events change when you need to either multiply or add. And so that's what we're going to go over next. So when to multiply? When events depend on earlier events or events at the same time. So the big clue when you want to figure out when you're multiplying is if you see the word and. So if I say, what is the probability of landing 2 tails and a head, then I need to multiply, right? Because I can either land a 1 out of 2 chance of landing a tails times a 1 out of 2 chance of landing a tails and a 1 out of 2 chance of landing a head. So that multiplies in total into 1 out of 8. So what is the probability of landing 2 heads in a row? Another way of thinking about this is each possible outcome, right? So I have 4 potential outcomes because I have 4 total possible outcomes because there are 2 choices in each. So I could either land a tail and a head, a tail and a tail, a head and a tail, or 2 heads. And because it's a 1 out of 2 chance to land a head or a tail, and a 1 out of 2 chance to land another head, we get 1 out of 4. So the way that I like to think about it is, imagine if your parents said, hey, you need to go do your chores, right? If they say you need to go wash the dishes and mow the lawn and take out the trash and go babysit your baby sister or help her with their homework, the probability of you being able to have free time after that goes down because you get more and more stuff added on top of it. Now, if your parents said, hey, you can either take out the trash or mow the lawn or wash the dishes, then the chances of you having free time goes up because the or means you get to choose which one happens. So similar to that is when to add, when events do not depend on earlier events. So the key word here is or. So if I say land either a heads or a tails, well, that means I have a 100% chance of this occurring because I'm going to say, okay, well, I have a 1 out of 2 chance of landing a head plus a 1 out of 2 chance of landing a tails. So that means I have a 100% chance of landing a head or a tail. So that's pretty simple because we know that heads or tails is only 2 choices. But what if it says, what is the probability of landing a 6 or a 2 on a 6-sided dice? Well, that's a little bit more complicated, but it follows the same exact rule. So landing a 6 or a 2, there's a 1 out of 6 chance of landing a 6 plus a 1 out of 6 chance of landing a 2. So that means we have 2 out of 6 chance reduced down to 1 out of 3. So that is our total chance of landing either a 6 or a 2 on a 6-sided dice. What is the probability of landing a 6 and a 2? Of a 6 and a 2, or wait, what is the probability of landing a 6 Oh, yeah. What is the probability of landing a 6 and a 2 on a 6-sided dice? Now, I threw this in because I wanted to distinguish between or here, let me change the color, or here, and here. Because I said or here, my probability goes up. Remember the example with chores? If I say you can take out the trash or you can wash the dishes, your probability is going to go up. But if I say you have to take out the trash and do the dishes, then your probability is going to go down. So that's your clue. So if we go over here, we say there is a 1 out of 6 chance of landing a 2, and then there is a 1 out of 6 chance of landing a 6. That means there's going to be a 1 out of 36 chance of landing a 2 and a 6. Makes sense so far? Now let's do some practice on figuring out when to multiply or add. So I'm going to let you guys look at this. Pause the video, take some time, and we'll go over the answers together. Okay, hopefully you guys went through this by yourself, so let's go through it. So probability that I flip this water bottle and it lands upright and I land a backflip. So our keyword is and. So let's go back to what it said. When to add, when to multiply, we multiply when it's and. So that means we're gonna multiply. Let's see. Probability the Cowboys or the Texans go to the Super Bowl. Well, if you're a betting man, you know you should never bet on that. But since I said or, we would add these together. So the chances go up. Probability a cell performs apoptosis or it is killed by a foreign bacteria. Keyword is or, so we add. Probability a student athlete gets an A on their biology test and scores a touchdown at this week's game. Now, where's the keyword and? So that means the chance is going to go down, so we multiply. Probability that Jerry's parents let them stay up on a school night and sleep over at Kendall's house. Multiply or add. And, so that means we multiply. Probability that everyone gets a 5 on the AP exam. Now, I didn't put and or on this one because I wanted you to have to think about this. Now, these events, do they depend on each other or are they separate? Now, I had to think about everybody getting a 5. So that means I'm asking for everyone. That means I'm saying and a bunch of times over. So I could say the probability that Jerry gets a 5 on the test, and Kendall gets a 5 on the test, and Steven gets a 5 on the test, and Susie gets a 5 on the test. So that would be multiply. Probability that everyone gets a 5, 4, or 3 on the AP exam. Multiply or add. So this is kind of a trick question, but technically the answer is add, because I'm saying or for these 3 options. So you can get either a 5, a 4, or a 3. So the percent that everybody, or the percent chance that everybody could get a 5, the percent chance that everybody could get a 4, and the percent chance that everybody could get a 3 are all being added up. Makes sense so far? Alrighty, now let's get into some biology problems. So this is going to be practicing multiplication. So what's the probability of a big P little p times a big P cross creating a heterozygous offspring? So we are looking for a big P, let me change the color, a big P and a little p in our offspring. So multiplication, we can think about this as each one of these having a chance of giving the necessary requirements. So this has a 1 out of 2 chance of giving a little p, and this has a 1 out of 1 chance of giving the big P. So our total chance would be 1 out of 2. And if we do a Punnett square, we can quickly see this. Screws my bad Punnett square. This is a little p. So we have big P, big P, big P, little p, big P, big P, and big P, little p. And so our assumption was correct. Not assumption, we knew it. And we have a 1 out of 2 chance of getting a heterozygous offspring. Now, let's look at a little bit more difficult question. And a cross between big A, big B, or big B, little b, big C, big D, little d, times big A, big B, big C, and big D. What is the probability that the offspring will be? And I'm not going to read that out again. So I wrote down here what we're trying to get. And we are trying to get first big A. So we have a 1 out of 2 chance of getting a big A from here and a 1 out of 2 chance of giving a big A from here. So we multiply these together. I should have wrote multiply up there too. And we get 1 out of 4. So now we have a 1 out of 4 chance here. Now for the next one, big B, little b. We have a 1 out of 2 chance of getting the little b here and a 1 out of 1 chance of getting the big B here. So we write, multiply, we get 1 out of 2 chance of getting big B, little b. So we write 1 over 2 here. Now, for this next one, C, we're trying to get big C, little c. We have again a 1 out of 2 chance of getting the little c times a 1 out of 1 chance of getting the big C. So here we're going to have 1 over 2. Now here we have a 1 out of 2 chance of getting the big D, and we have a 1 out of 1 chance of getting another big D. So we multiply those together and we get 1 out of 2. So we have 1 out of 2 here. Now, do we multiply these all up together or do we add them together? Well, let's think. Let's go back to our example with chores. Am I being asked if I can pick between doing the dishes or mowing the lawn, or am I being asked to do all of them together? The answer is I'm being asked to do all of them together. So we are going to multiply all of these together. So we have 1 over 4 times 1 over 2 times 1 over 2 times 1 over 2. And that gives us 8, 16, 32. So 1 over 32 is our answer. That is a chance that we will get this as our offspring. Not so bad, right? Alrighty. Now let's get into a practice with addition. Now, I'm not going to lie to you guys. I don't like doing addition with these problems because they kind of get a little confusing, but I will show you how to do it regardless. Oopsie. So we have big E, little e, times little e, little e. Now, what is the probability of the offspring that are heterozygous? So we are looking for big E, little e. So what we can think about in terms of this is what each one gives and then adding those up. So we could potentially have a Punnett square. Let's write our Punnett square out. So we have big E, and little e, little e. So we have big E, little e, little e, big E, little e, little e, little e. And so we have a 1 out of 4 chance of getting a big E right here, and a 1 out of 4 chance of giving a big E, little e right here. So that means we would add up 1 out of 4 plus 1 out of 4, and our total chance would be 1 out of 2. Now, if we just did it the multiplication way, we would easily see that this is 1 out of 2 times 1 out of 2 chance of getting the big E, and then a 1 out of 1 chance of getting the little e, and we get the same answer, but much quicker. So I prefer to do it multiplication, but whichever way makes most sense to you, that is the way you should do it. Alrighty. And a cross between all of this, what is the probability that the offspring will be either this, or this? So I'm going to let you guys do that on your own. Pause the video, and then we can work through it together. So the key is that you add up the total chance together. So we do the exact same thing that we did before, where we multiply to find out what our chance of each possible offspring is, and then we see that it's a 1 out of 16 chance for all of them, and then we add them up together. So I worked out everything here for you guys, so it should be nice and clear, and this is all that you have to do. So that is probability in a nutshell. It isn't too bad. You just have to remember when you multiply and when you add. Alrighty? It was great working with you all. Hopefully you guys understand it. Please leave any questions that you might have, and I'll be sure to look at them and answer them if I can. Alrighty, y'all. Have a good one.